Alright, hello everyone, and welcome back again to another session, online session. Here's our to-do list. Today we are actually going to cover how to override to string, get hash code, and override equals. The best practices as well of how to override to equals, as well as introducing generics, as well as by the end of the class I'm gonna show you how to decompile your C# application and see what the compiler have generated for you. The code, for example, you have written a compact code and you would like to see what the compiler have done for you, or if you would like to see the intermediate language code, this also I'm gonna show you how to do that, and it's very easy. It's just gonna be like some sort of a perk by the end of the class, just for fun, so you guys have it, and for those who love to optimize their codes as well. Alright, so without further ado, let's get started. So let me grab Visual Studio. I'll just move this on the other monitor so it will be easy to get questions and see them. Okay, so let's first talk about how to override certain functions. So let's say we're gonna add a new class, and I'm gonna call this the person class. Again, our great victim over here who has to be a person. And a person, you know what, how about this? It's kind of boring, right? I think designation is like that, I hope. And a public int ID, I think. Or did I? Okay, let me like ID. Oops, I think I introduced something bad there. Okay, and let's say we have just an innocent constructor which doesn't have anything, and another constructor, for example, which takes string designation, and I hope you're gonna excuse me if I mistyped it, and int ID, and I will go over here and say this designation equals to designation, and this dot ID equals to ID. Now there are, as we already know, Vlado lock is used for multi-threading if you would like to lock a certain variable, but of course it's not its position to be written there. It's just a reserved keyword for multi-threading. So if you lock a resource, nobody will access it. No, not like final or constant. This is right now regarding how many processes can access the same variable. It's about the data access. Alright, so as we already said, that any class that you write in C#, exactly, thread access, any class you write in C# and any class that exists in .NET Framework they always inherit from object. Okay, and usually when you have an object, let's say like a person, or sorry, we had an alien right now. Alien 7 of 9 equals to new alien, and there you go. For all the Star Trek fans, right? Now, if I type 7 of 9 dot, we get additional methods that we don't have, which we actually have inherited from the object class. Now you have 4 of them. One of them, which is, of course, you cannot override, because you know, if you would like to get the type of an object, it has to give you the true type of the object. C# is really type safe language. It doesn't allow you to do things like in C++, crazy things like in C++, where you can make some objects behave or act like they are not who they are. So basically getType is the only method, let's say, which you cannot override. However, equals, get hash code, and toString are very important to override. So how to override them? If you say public override, let's grab toString for instance. Now why would you like to override such a thing? if we go over here and if I say, alright, let me use the full constructor here, and I will put the name oh my 7 of 9, and I will put the ID, let's say 79. Okay, if I try to console dot write line, and I will just simply pass in 7 of 9, and if I hit Control F5, what I will get here, I will get my namespace path dot the class name, which is in my case alien, not a person. Okay, so where's my there you go. So basically it's going to be the namespace, again, the namespace dot the class name. Now this is because we have actually used the toString method which is built in into the object. By the way, if you erase this and hit Control F5, it will be the same thing. Okay, I just when I said here public override to string, I've just simply called the base class, which is the object class, dot toString method. So if I don't provide any implementation here, it will call immediately the base class. And as well, by the way, this is the same. This part, this line of code, is exactly the same as this part of code as well. It just the compiler recognizes that you are trying to print out the object, so it will immediately call the functions, call that toString method automatically. Would be object class. For Vlado was asking base class, for Alien would be the object class. As I already said, any class that you create in C#, anything that exists in .NET Framework, they inherit from the Godfather. Remember the Godfather picture which I put? You cannot forget Al Pacino's picture which I put there, you know, representing the Godfather of everybody, of all the object classes, right? Class over all classes, indeed, sir. Now, what I want to write here. So basically, you could return this. Let it be like this. So name or designation plus this dot name. Designation, sorry, plus ID. Somehow I'm in the humanoid mode yet. Is going to be plus this dot ID. Now you could write it like that, by the way. It's the same as this one, string.format, and then you could pass in designation 0, ID 1, and right here we could just simply say this dot designation and this dot ID. Alright, so this is one way of writing it as well. And by the way, this is going to be assigned to this, and this part is going to be assigned to this part. So the compiler immediately on the runtime will just simply replace these guys accordingly. So the order of the appearance of these variables are they have to be matching the part which you put it in the string. Otherwise, you will get mixing everything up. Okay, so we can write it that way as well. Now, if I hit Control F5, I will get 7 of 9, and the ID is 79. So we are good to go when it comes to overriding to string. This part is easy, nothing fancy. Okay, so let's get to the equals method. So basically, equals method is used in order to compare two objects if they are actually the same. By the way, this is different it's different than the referential equal. So for example, if you say if new alien equals to new alien, I'm just you know making them up here. Here it actually tries to check out if we are pointing to the same reference. In fact, it's like, actually it's basically, it should be yeah, well basically this is it. In fact, if you see even Microsoft's MSDN about the subject, it's quite, in fact it's quite interesting. So basically, let me see here, I think I kept it just for this class. There you go. The guidelines for overloading equals and the operator equal, and you will see that if you override the equal operator right here, it actually tests if the reference equality are the same object. So they are actually checking out the reference. Are we referring to the same object or not? It doesn't say are these equal, are these objects are similar. It just says that these objects, they have, am I pointing to the same reference or not? Do you get the difference? Do you understand what I'm talking about, guys? Right now it compares the references. It doesn't compare the objects themselves. Okay, so let me go ahead and let's start implementing this. So I will just simply take out this away. Now the best way of comparing, the best way of implementing it according to MSDN, right now this is how you should do it. So you are checking if the object is null. If it is null, then you just simply return false, right? And then if the object is not null, basically, so you're gonna be coming to this part. So I'm gonna define an alien, alien compared to, I usually name it that way, equals to obj as alien. I've already covered what is the difference between as and is. So basically, if this fails, it will give me null. This guy will be null. If it doesn't fail, then we have an object of an alien, and then we can go ahead and compare them. So here I'm gonna just simply say if alien compared to equals to null, then I will just simply say return false. And then if everything just goes fine, then I will just simply say return this dot designation, hang on a sec, equals the alien compared to dot designation and this dot ID equals alien compared to dot ID. Alright, so this is basically, it just says if both objects are the same or not. So basically, when you are, you know, it's the same thing when you are comparing two things in real life. So if you are comparing two persons, you will say, okay, you know, it's like people comparing your ID or of your passport or your ID card to you itself. So you hand out, for example, the your ID card to the policeman, let's say, if he asks about your identity, and then he grabs it and he says, okay, the picture is the same. So he's not actually checking out the whole person object. He just right now start comparing attributes. Okay, the picture is the same? Is the guy having the same name? Is the guy having the same height, the same weight, and so on and so forth? Of course, the height and the weight and everything is not mentioned in the ID card, but this is how we compare stuff. We start comparing their components. If their components are the same, then they are the same thing. Alright. Now Microsoft as well is stressed over that we implement as well another equals overload function, which which takes an object of the same class as a parameter. So it's going to be alien, and I'll just simply grab the same name for a very good reason, because I'm gonna grab this whole part, and in fact I'm just gonna take this out and we are good to go. So they said it will enhance the your code efficiency. It will be much more optimizable, and you will see in a second why. So basically we are seeing if this actually alien object equals to null, they just simply return false, because you cannot pass any other object than alien here. Otherwise, just start comparing those two. If any other kind of object starts to pass, just to get past, this guy will kick in automatically. Okay, so let's see how this will serve us. Right now here I'm gonna just simply say I'm gonna create another alien. 8 of 9 equals to new alien, and we're gonna have 8 of 9, and it's gonna be 89. I could check it out like this: if 7 of 9 dot equals 8 of 9, then I'll just simply say console.writeLine they are the same, else console.writeLine they are not the same. Okay, if I hit Control F5 right now, they are indeed not the same. So be it. You need TPOL, but a little bit later. There's one more thing here. Let us try to have our application speaking to us. Because we are still working in a console application, so that's why we can see these stuff. Console.writeLine, I will say equals method override method is called, and here I'm gonna just put out colon 4, and I'll just say this. By the way, you could do this as well in console.writeLine. This dot designation. This is as well possible, and I will put this one as well right here. Equals local method, because this is our overload. Okay, let it be, say overload local method is being called. Now if we hit Control F5, we'll see some interesting stuff going here. So basically the equals overload local method is called for 7 of 9, and it took 8 of 9 as a parameter and start comparing them. And as you can see here, this method has been called, this one wasn't. Now if I pass in new object, for example, let it be not new object, let it be new list of integers, right? Who cares? I'm just passing something in there. Oh yeah, one more bracket needed. Now if I hit Control F5, you see equals override method is called for 7 of 9, and of course they are not the same. And as you can see here, this happened because I didn't pass an alien anymore. I passed an object, a class that inherits, or an object of a class that inherits from the object class. So that's why this guy kicked in automatically, and immediately it started calling this method. Okay, so that's why Microsoft has said for efficiency purposes, instead of trying to cast here to an object that's for sure it is an alien, you just simply create an overload, which is going to be called automatically. So it's less checking, and it's faster. I mean, it's much more efficient, if you know what I mean. Are we good on this? Guys, are there any questions? Okay. Somebody's typing. I'm waiting. It's okay. Take your time. Don't be scared. The last line in the override is redundant. The last line in the override. Do you mean this? Or which line? There are line numbers. Just give me the line number. This one, 38, line 38. Is that the one? Okay, so why it is redundant? Why you think it's redundant? Do you mean that I repeated line 38 and line 47? They are redundant? Is that what you are talking about? It will never get to that one. No. In fact, it's like this. If this fails, okay, so here's the thing. If this becomes true, it will never get here. If this fails, it will get to here automatically. Take your time in typing, it's okay. Yeah, thank you, Armin, very much. Do not use that. It's better to write it in Bosnian rather than in Google Translate. It will be crazy. But if we are comparing an alien object that override the function won't be run. If you are comparing an alien object, no, of course not. If we are comparing an alien object, a real alien object, then this part will not be running, this part will kick in. Is that what you were asking about, right? Yeah, okay, you see, also, if you haven't noticed, if I type in 7 of 9 dot, and if I say equals, let me open a bracket here. You see this? You have two overloads now, right now. You can choose which one we would like to pass in. So it says either you can pass anything in the .NET world, and it will go inside, but it has to be compared and it has to be checked out if it's an alien or not. And this one will accept only an alien. If you pass in an alien, it immediately thinks that you are calling that method, not the overridden method. You get me? The compiler will say, okay, you are trying to call the overload, and this is it. Are we good, right? Okay. Okay. Since are there any further questions before I go further, actually? Yes, sir. Now, I will leave this right here and let us talk about generics for a second, because this will lead us actually it will not lead us to get hash code, but I would love to use the feature which we have in generics, just to be relaxed right now, because I really don't like to use non-generic stuff. Now, if you remember, if we say using system.collections, I could define an array list because it exists in system.collections, and as you can see here, system.collection.array list. And here in array list, I could say .add, and as you can see here, I can add any kind of object I want. So I could add here a new alien. I could add in here a string, which is going to be right, and this is the problem which I talked about last time. And if I add here one more integer, so this is like an array that accepted many items, and it compiles and it will run and everything will be just fine, because it allows this to happen, and it can happen. However, you as a programmer you're gonna actually suffer from such a list, because you cannot iterate over it normally. You cannot do a for each loop, because if you remember, I was always talking about the for each loop that I say you have to have the same container. If you remember Colin from the last time, Colin always had to have the same bucket. If he doesn't have or if it doesn't have the same bucket type, it cannot hold the variable. So right here I cannot say an alien for every one of them. So if I say alien in my array list or array list, which I define it that way, if I say console.writeLine alien, if I hit F5, the application should crash right now, and it says unable to cast alien to string. It's incompatible. Of course, the only way of resolving this issue is to have an object, which if I have if I compile it and run, it will work. However, if you would like to do some certain operation, because you will not always print a list, you could, for example, would like to change the alien's name if you want to something else. So this won't be possible, and so that's why programmers loved all the time to create an overload or some sort of a wrapper around the collections which they had, and made something which is called the strongly typed collections. And so Microsoft in C# 2.0, as far as I remember, they came out with the generics, and you could, for example, define something like this. And you say alien list equals to new list of aliens, right? And right here, if I say alien list.add, you see it accepts only an alien. It cannot accept a string, it cannot accept an integer, and even if I force it, it will give me an error. It says the best overloaded method match for the system.collections generic list of aliens .add, it has to add an alien. You see, it's written right in front of you, has some invalid arguments. So it really needs an object of that type which I've already defined. I think if my memory didn't fail me, I think this is the template classes idea which is in C++. Am I right, guys? Alright, so this is basically it. So basically it's a chameleon. It adapts the collection, any generic stuff which you are creating, it adapts to the type you have defined. So if this suddenly becomes a string, and this is a string, right now it's possible. Right now it is acceptable, because right now this guy becomes a list of strings and it needs a string item. Later on in the next classes, I'm going to show you how to create generic classes. Maybe if we have time today, I can show you something, some of that, but I don't know, we will see later. Maybe probably next class is not this one. Someone is typing. Just take your time. It's okay. Armin, I don't understand you. Okay. Anyway, oh yeah, now I understand what you wanted to do, but it's a typo apparently. Okay. This is basically it for generics. And generics exist, all the generic collections exist under system.collections.generic. It is very important that you reduce all your errors to the compile time errors. Alright? So if you have everything compile time error, you as a programmer are gonna be happy. And you will have less exceptions that you should handle and less exceptions that could explode in the user's face, which you really don't want that ever to happen. Alright, and so that's why I don't advise you to use this most of the time actually, so don't do that. Always use the generics collections, alright? This is very, very important. And of course when I erase the system.generics, system.collections, the array list right now is completely invalid, and of course it doesn't exist anymore. Alright. Now of course you have everything, all data structures that you could imagine available for you in generic version. So if you say stack, you have a stack of integers or a stack of aliens or whatever you can like to call it, stk equals to new stack. You have, I think, linked lists of, let it be, aliens, I mean, right now you just go ahead and explore. I don't know, sorted lists, they have sorted, and sorted dictionary even, that's awesome. Sorted list, and then you have to define what kind of it's going to be, float for instance, or something like that. SRT, LST equals to new that, and so on and so forth. Everything, all collections that you can have in C#, all of them, they have their own generic versions. What's wrong with this thing? Am I missing something? Okay. Well, something's wrong, gone crazy, I don't know. Okay, it's okay, let it be. Let's stop at this part. I will check it out later why I cannot. How come sorted list is a class? Oh yes, it actually takes a key and a value. Sorry about that. Okay, I didn't notice. Okay, so you have a stack, you have queues, you have all possible data structures available for you in order to use I mean generics basically. Alright, since I covered generics right now, do you have any questions regarding it, guys? Hello, anyone? Do you have any questions? Okay, now I can move ahead and show you this part as well. So the equivalent of a hash table in in the generic collections are dictionaries. So if I have a dictionary of, let's say, an alien and a string, for example, and I call this alien, I don't know, list or dictionary equals to new of that. Alright, and I put the alien actually at the key instead of a value for a very good reason, and this is where the get hash code is going to come into play. Now of course if I say alien dictionary.add, it will accept an alien as a key and a string as a value. So I could pass in, for example, 7 of 9, and as a value, for example, I'll pass its designation, for example. Okay, so basically you don't need even to cast anything. You don't need to grab anything, or for example, if you would like to do a for each loop, so it's gonna be for every. By the way, in order to loop over, in order to for each loop over a dictionary, you have to type key value pair. This is how, in fact, .NET Framework prefers, the people who made .NET Framework, they prefer to create some sort of a structure, a struct, which is a key value pair like this, which has the alien and a string, right? And the alien dictionary. They preferred it to do that way because if you look at the dictionary is just a simple a key and a value, and they just simply imagined everything like a row. So you can have so one row is going to represent an alien along with a string, or a word along with its translation, and so on and so forth. And right now I could just simply say console.writeLine item, right? And I could, before I go ahead, I will just simply okay. Now if I hit Control F5, now let me see. Okay, this actually has been called, but then it displays for me the items. As you can see here, the items has been displayed like it called its to string, and it's been displayed in these interesting brackets. Okay, because it denotes that this is an item, a row in my dictionary. If I didn't override the to string method, in between these brackets I would have had I don't know, Miss Online Consultation 2 dot alien. Okay. Now, as I already said before, when it comes to hash tables, in order to add any item in the hash table, you have to have all the keys are passing through a hashing algorithm. All right, and then once it passes through this hashing algorithm, it goes inside. It gets added. If two hashes are the same or similar, and you are trying to add these, for example, you added, let's say, an alien 7 of 9 as a key. So alien, the 7 of 9 as a key is going to have a certain cache, an X cache, for example. And if you're trying to add 7 of 9 again into the same dictionary, you will get a collision, because a hash table or a dictionary doesn't allow to have two same hashes in its table. So you'll immediately get an exception that this item already exists in the dictionary. So that's why immediately your object should have, every time when you add to a dictionary, your object actually creates a hash for it. Okay. Now it is preferred that you create your own, for example, for every object that you have, for every class that you have. I don't know why I have this. You see, it overrides the equals but doesn't override the get hash code. And it's quite good practice to override the get hash code as well. So let me show you what it does here. So I say override, and this is the only method which is left, get hash code. And let me call this right here. I could simply say return this.designation.get hash code, and I'm calling the hash code generation of the string itself, because designation is an object of a string, and of course the string class have overridden somewhere the get hash code. So basically I will get a unique hash code for that string which I'm having. By the way, if you have the same string, you're gonna have the same hash code. Remember that, because it passed through the same formula. Plus, for example, this dot ID, which is an integer dot get hash code. So I'm relying on Microsoft that they have already implemented the get hash code for example, for an integer variable. And if you would like to see this in action, I will just comment that, Control KC, and let me just here for a second. If I just put this as a 10, oh well, let it be a string because you will not see it. S equals to colon here. and if I say console.writeLine s.getHashCode, you will see an interesting number. You see? This has been automatically generated for me. This is what the getHashCode has. This is what when Microsoft made the string class, when they overridden the getHashCode, if I have any string, it will have such, you know, number. Now, of course, not all of them is going to be having the same. Every different string is going to have a different hash code. Okay, so basically what I've done here, I've overridden my method to create my own hash code. Okay, like this. I just combine the designation plus the ID, and this is it. Some people like to multiply, start, you know, saying, okay, I'm going to multiply by 17, dividing by 32, whatever you would like to do. You're going to get a lot of people making a lot of several ways of getting a really nice distribution of hash codes. Okay, and all right, let's see. All right, so let's get started. I will, in fact, let our application speak to us a little bit, right? It's good always that make your program speaks to you, so you will not feel lonely and such. Get hash code override method is called, and then 4. Okay, and then I will say, okay, I will just put 0 there. This dot designation, right? Okay, so I can hit Control F5, and as you can see here, okay, wait a sec. Let me try to separate this. By just introducing it that way, so you can see what I'm doing here. So okay, let's leave the override equals. Now have a look at this one. When you add to the dictionary, the dictionary will immediately generate the get hash code. It will actually call the get hash code right away, automatically. And when it calls the get hash code, if you didn't override it, it will call the get hash code from the object class, and it will give you a generic one. And it happened for both of them. For each object you are adding, it gets the hash code. Now this is a very, very interesting concept, because let me see here. Okay, because if you would like, for example, to get something, so let's say I will just separate this again, and let's say I'm trying to get something. Let's say I'm trying to get the designation of 7 of 9. So console.writeLine 7 of 9. Actually, sorry about that. Alien dictionary, and then I'll pass in my key, which has to be an object of an alien. All right, and it will return to me as a value as a string. Right? So this is how it works with dictionaries. If you pass the key as an indexer, it will immediately return to you the value. So if I hit Control F5, you see, get hash code has been called. Then the equals override method has been called. Then you get the object. Now you see, it actually, there's some sort of a succession in calling the methods. In case that the hash code, I think this is how it works. For example, getting a hash code to compare. For example, it says, okay, every object in there, let me see your hash code. If the hash code matches, it doesn't see this as enough sort of proof that these are the two same objects. So it will immediately call for the override method of equals. It will immediately call the equals function. So it calls the object.getHashCode method, which we have overridden, and it immediately calls the object.equals method, which we have overridden as well. And then if everything goes true, then it will actually spit me out the object. If not, you will get an exception, or you will get an error that you are hunting for something which doesn't exist. Now, I think if the hash codes are not the same, are not similar, then I think it will not even call the equals override. I mean, I've tried it several times. It didn't work out. It didn't call the equals if the hash codes are not the same. I think this is how it works. I don't know if I'm actually 100% sure about it, but this is after a couple of tests. It appeared to me that way. Okay. So this is the succession of calls here. And if you are making a dictionary of objects, if you are 100% sure that your custom class is going to be enlisted inside the dictionary, it is always advisable that you implement a hash code for it. And according to Microsoft's recommendation regarding dictionaries especially, they say that I will just get it to you right away, so let me find it first. Sorry about the noise, it's actually beyond me. Alright, let me see here. Okay, these are all the methods. There you go. You see, the speed of retrieval depends on the quality of the hashing algorithm of the specified key. So it is very important that you that when you are making a hashing algorithm, if you're making some sort of a complicated hashing algorithm, make sure that it's really efficient and unique. So it will be faster for .NET Framework to actually catch it out. All right. And for those who are interested in the size of how many objects you can stuff in a dictionary, I think it said somewhere 2 billion for a 64-bit system, and I cannot there you go. For a very large dictionary key value objects, you can increase the maximum capacity to 2 billion on a 64-bit system by setting the enabled attribute in the runtime environment. So GC allow very large objects. Okay. So this is basically regarding the get hash code, which works really well with dictionaries, especially. It could work with other things as well. I haven't worked with other things other than dictionaries, especially when it comes to get hash code. Maybe you can have anything else to work with to use get hash code in. This is for overriding equals and to string. Any questions regarding this part or this topic, guys? All clear. All right. Since it's in fact all clear, let's get to the fun part, right? There are a couple of things that I have been using. I planned actually to show you. Somehow I get interesting redrawing problems. JetBrains.peak is a free C# decompiler. So it actually recognizes the .NET framework until I think 4.0, and currently by the time of this recording and by the time of holding this lesson. And in fact, you can see the implementations of certain classes and collections right here, in fact. However, I remember I've been seeing I've seen lists and such. Hang on a sec, let me try to rerun this again. So JetBrains. Because I remember I actually have seen the there you go. So this system.collections, system.collection.generics, and you could go to a list, for example, and you could see for yourself how a list class is implemented. Now, of course, you're gonna see a lot of a lot of annotations that are not documented or you haven't seen before. Don't worry about that. But right now, as you can see here, this is some sort of approximation, or I think the decompilation of the implementation detail of how people have programmed the, for example, less class for you in the .NET framework. Okay, so this is kind of very, very interesting thing to see. Okay, now, all right, there you go. So far, you can see. Okay, now there's also an interesting program by, I think, Sharp Develop, I think. ILSpy, it's called, and with it you can see the VB.NET code and C# code and intermediate language code. So let me go ahead and go over here and say open project in a folder. So right now I'll go to bin, debug, Control C that, so it'll be fast, right? And open, Control V, and right here I'm gonna open the Miss Online Consultation 2, which is the same project, the very same project which we were working on. And currently it's decompiling. And as if you remember from the first lesson, I said already that even the exe file which Microsoft have made, sorry, I lost track here. As I already said before, Microsoft have made even the exe files which are being compiled, they contain IL code. They don't have native code, and they get interpreted. So that's why they are not normal executable. They actually get by the common language runtime. They are being grabbed by the common language runtime and they start working. So basically you can decompile an exe easily. So if I go over here, spread out my classes, I get the alien class. Even though I opened an exe file, I just simply get the classes which I have made. And I get immediately all the things which the compiler made for me, or the compiler actually have generated for me. And as you can see here, most of the code which I've written, everything is just pretty much the same, nothing fancy in here. And if I go ahead and expand the program class like this, you can see our code as it should be, right? Now if I go here over alien, now watch this. Have you noticed this? I've used only system and system.collection.generic. However, I have been importing all those three. Since I haven't referred them into my code, they haven't been called upon yet. They haven't been included into my exe file because I don't refer to them anyway. So there's no need for me to hog resources to get these libraries and load them in the memory, right? So if I go over here into my alien class, I have to expand all of this. And if I go over here, I can choose this to say IL. So please show me the IL code, the intermediate language code, which has been generated for me. And as you can see here, this is how the intermediate language code looks like. For example, for this part. Okay, so this is how the sorry, I have to expand some stuff so you can see. So these are the it really looks quite closely to assembly language. You know, it's full of opcodes and such. And for example, if there's an opcode you would like to know what is it, you just simply click on one. So for example, like call. So right now it says call field. What is it about? This is an opcode. So in an opcode it says, you know, calls the method indicated by past method descriptor. So it's basically, it's made for calling methods. And here it says call instance, call method of an instance of an object that returns a string, get designation. Alright, so basically this is what's happening behind the scene. You get your the compiler actually dissects those stuff and spit them out into an intermediate language code that gets interpreted later on by the common language runtime and starts to be invoked line by line as long as you execute them. Okay. Now, for example, you could, why I have two of them, because JetBrains actually cannot open the IL code. However, if I go over here, JetBrains actually could show me the compiler generated code, which is not beautified anymore. So for example, I have a button here which says show me the compiler generated code. So this is how the compiler spreads out my code in real time. So this is if I write a code that is really compact in C#, the compiler of course is quite smart. It gets recognizing it and starts spreading it out. So this is how it actually works, and this is how it starts spreading my code out. For example, the automatic properties, they are still, I think, they're still the same. So you have this return. You see, if you remember, this is the full property, not the automatic property which we're talking about. This is before. Remember, automatic properties. And then when I hit show me what the compiler have done for me, and you can see right now the full scale property which the compiler generated for me. And this is how your IL code looks like. I mean, not the IL code, the code behind the IL code looks like. Okay. If we go to program, let's say, if I hit, I think there's nothing here fancy to show, right? If I say expand, well, okay. But basically nothing fancy in here. Everything is pretty much the same. So I think right now it goes directly to IL. Alright. And I will actually probably use the dot peak later on in the future classes to show you certain things about especially working with IEnumerables and these stuff, so you can see how stuff actually works. I think if I, in fact, if I do a for each loop here, you will see it in reality how it looks like. So for each key value pair of alien and a string, an item in what was it? Alien dictionary, right? console.writeLine item. I didn't have any for eaches, right? So this is the one. So if I hit Control F5, it's fine. I don't know if I can actually reload this. Let me see, can I reload? Oh no, sorry, this is the IL one. Let's see. Did it change? Nope. Ah, here it is. It's changed actually. So let's see. Well, it didn't actually do it for me. It's fine. It's okay. I will keep actually this to the next lesson when we cover extension methods and so on. I'm gonna show you how actually the compiler spreads out the for each and how it looks like literally there. Okay. So this was actually like, this is for fun. This is more educational. If you guys would like to go ahead and explore more, learn more how .NET Framework has actually people who made .NET Framework, how they resolve certain issues and such. Let me see here. I think you could be quite interested in the object class, right? How it looks like. I'll take out the generated code so you can see the normal thing. So as you can see here, the toString, the basic toString method, it just simply gets the type of an object and converts it into a string. Right now I don't know about this part, runtime helpers equals. This one I have to check out in the documentation. By the way, some parts in the .NET Framework is not documented, for example like these. And you can see the answers over Stack Overflow about these guys, but I think they are more like some sort of magic optimizers in getting the reflection of an object, so getting the type of an object and so on. Reference equals, you can see it right here if you are interested. I think there you go, you see it's a static one, so you can just hit the dot key and you get the reference equal, and it compares if you are referring to if two objects are sharing the same reference. Okay, so this is one. Nah, I mean, you could guys just have fun with this stuff. Just read them and see what all these methods are about. You could learn more about them. All right. So I think this is it for what I wanted to cover. Do you guys have any questions regarding what we have covered tonight? And everybody's AFK, right? Okay. Well, yes, indeed. These stuff are quite really easy. You just simply need to just sit down and practice them and trying them in your hands. Because if you just watch it and then you go to sleep over it, I don't think it's a really good idea. You have to really try to try them out. Get your hands dirty. This is the most important thing. Just get your hands dirty and you'll be just happy. We love always to play with clay and such, making things. Get your hands dirty. So always get your hands dirty. In work, of course. All right. Then, since there are no further questions, I will conclude this session and we'll stop the recording. Thank you very much.